course. And I am Aida Fitri from Chemical Engineering Department, University Putra Malaysia. Will talk about the project of process control that being proposed by our team. So basically, we will develop our own process control system, which is water level controlling with the simplest equipment, which is we have two bottles, two unused bottles, tubing, two water pumps, and ultrasonic sensor, and Arduino with the relay to on and off the circuit, and a laptop for the coding. So basically, we are going to control the water system into a certain level that we desire, and we'll coding the system through Arduino coding. That could be obtained from the internet itself, but we alter a little bit, and we after we developing the system, we analyze it. So we have an analyzer team and we have mechanism team, and this video will tell you about what we have done.
Very good evening to Dr. Musab and Shijin from Gas Process Control and Instrumentation, Chemical Engineering third year. So I'm here to explain to you the project, the mechanism my group has done. So basically, our project is about a system to control the water level. Basically, we use two bottles. One is 5-liter bottles, which is a big tank, and a small one is a 1-liter bottle as a small tank. So as told by Aida before, we have two pumps in both two tanks. We place the pump in the two tanks, and we will control. And we have one ultrasonic sensor up in the big tank there, so that the sensor, the water will pump from the small bottle, which is the 1-liter bottle, into the 5-liter bottle, and the ultrasonic sensor will sense the water level, and we have set the point to 17 centimeters. So once the water rise until 17 centimeters, so that's the set point, and if the water continue rise up, the pump in the big tank, which is the 5-liter bottle, will pump out the water back to the small bottle, so that the water is maintained in 17 centimeters. So yeah, that's all. Thank you.
So we have done the experiment. Now we are going to show you what we got after we done the experiment. So first, we ask our result until 45 seconds. Then after that, we are going to show you the result. So for the blue one is how we plot the time versus what we got. So this is the blue one is our scattering plot. Mean that our data that we got is not it's not fixed. Means it's flat rate, that upside down is flat rate, it's not fixed. So what we got, so we have plot the Y bar to get the smooth line for the graph. So first, we set point for the time constant about 10. and 25 because we can see from the blue one, we can see that at t to 10 seconds is fall down, and then for the second time it's fall down at 25 seconds. So for the step change, we pick one. For the first one is pick 1 because there's a up, is going up. Then for the second one we take negative because it's falling down. Then the second one, the third one, we take third negative 2. So we get the orange one for the graph. It's stepping down like this, so like this. So we are going to use solver to get what to use it and simulate. So let's use it. So we are going to use a solver. So for our solver, we want to make sure the sum error is close to 0. So first we pick the solver, we pick the sum error here. Then by changing theta, tau and k. So we're going to solve it. Are we going to get the answer? We are going to get pop. Tada! That's our answer. So next, we are going to do it at a Simulink. So we pass to my friend Nazmi.
Hi. Okay, now I will proceed the calculation about after we got the value from our data regression. Okay, first of all, we will use the value of theta, tau and also k to get our GP. Okay, this is our GP. The general form of our GP is the first order GP. That is equal to k exponential power of negative theta s over tau s plus 1. Okay, we will insert the value of theta, tau and k into this GP. Okay, that is our GP. And we assuming that GM and GV is equal to 1 and there is no disturbance in our process. Okay, to proceed with Simulink, we need to identify which cases that we need to use to find the PID value. We will use the IMC controller setting for parallel form PID controller. Okay, we'll use this table as our guide. Okay, based on our GP, our case is case H. Okay, from this case, we will find the P, I and D value. We will use different tau C. The first tau C is 0.5533. Actually, the 0.5533 is our theta. The second tau C is 2, and the third tau C is 3.5. And from that, we will calculate all the PID value, and we will use Simulink. Okay, after we got all the PID value for tau C equal to theta, tau C equal to 2 and tau C equal to 3.5, we will use all the value and also the GP, including the delay that we have in our process, into Simulink. And this is the Simulink that we have done. Okay, now I will show the result of our process control.